Matt, you gotta wake up. You're late for electronics too.
Oh no! If only I'd made a mechatronic system that could serve as an alarm.
I created a mechatronic system to serve as an alarm. It features a piezoelectric speaker and a servo motor and a photoresistor. When the photoresistor senses light, the motor will turn and activate the buzzer. There's also a snooze button included that, when pressed, will cut the buzzer for 10 seconds. After these 10 seconds, the buzzer will then resume. So this is my circuit for the mechatronic system. Basically over here you have a voltage divider with the photoresistor in line with a 10 kilo ohm resistor. That'll spit out ranges from around 300 to 1000 from the analog read. Over here we have the piezoelectric speaker and a button with a pull down resistor. So this is the code that I used for the system. First off, I established my inputs and outputs for the different pins. Then I used the map function to translate the analog read of the photoresistor from the range of 700 to 230. That way we can change the angle for our servo motor. Basically, the more light that the photoresistor is receiving, the greater angle the servo will turn. And you can see that done manually with the digital right, high, and low commands. Put the duty cycle of T period minus T control. Now down here, it says that if T control is greater than 1900, which basically means it's light in the room, that the serial monitor should read 1, which will feed into processing, and then sound the alarm with a half-second delay in between. And then down at the bottom, if digital read 2 is equal to 1, or the button is pressed, it should print a 3 to feed to processing and delay for about 10 seconds. So we're currently using this setup to get to the proper height of my blinds. My hand is covering the photoresistor, which would simulate a dark room at night. And while it's night outside, the blinds opening would signify more light entering the room. So you'll see when I uncover my hand, the buzzer will sound and the blinds will open. 3, 2, 1. So this is the code that I use for processing. It's very simple. It'll basically read in strings like we've done before from the Arduino. And if the string is 1, you'll see that it prints the text, blinds open, good morning. And if it reads a 3, it'll print snooze activated. Those correlates to the values printed that I explained in the previous video. So this is a more close-up version of my circuit without interacting with the blinds, just for simplicity. My hand is still covering the photoresistor, and you'll see that when I uncover it, the alarm will start sounding, and it'll display a message, blinds are open and good morning. Right here is my snooze button. If I press it, you'll see snooze activated and the buzzer won't sound for about 10 seconds. So we're gonna wait. And it reactivates. And if I press the button again, it will turn off. So this is the processing sketch I tried to use the first time around. It essentially works as a timer for the alarm, but I couldn't find a proper way to implement it in with Arduino, but I will show it now. It will have a snooze active timer and turn yellow at 6 seconds and turn red at 3 seconds to indicate you're close to being done.
Oh, thank goodness. I took electronics too and now have an alarm to wake up to every single morning. Thanks, Dr. Mitchell.